So we're going to define the torque, and we typically use the Greek letter tau for torque. And it's given by the product of the distance away from the axis, the magnitude of the force, and then the sine of the angle between the radial vector and the force vector. But I don't want you to focus too much on that. I want you instead to have in mind the picture that I tried to illustrate here. So if I'm pulling on the rubber band and the line of the force of the rubber band passes through the axle, then it doesn't cause a torque. And I want to show you that it doesn't matter, in a sense, where the force gets applied if we just regroup that expression a little bit. So we have the torque is equal to the magnitude of R, the magnitude of F, the sine of the angle between. Okay, so let's say I have my axle here, and I have a force F that's applied like this. What's the definition of the angle between? Well, I can either translate F back so that the two tails have a common origin, and then define this as the angle between R and F. Or I could simply extend this and call that angle theta RF. No matter where I put this, it's going to be in the way. All right, let's try one more time. Up like that. Okay, but the line of action of the force F, just the line that includes that vector, might look this way. And I want to persuade you that if this is the angle between the two, as is shown here, by, what is it, the alternate interior angles are congruent doohickey thingy. So this is theta RF. And this distance, this length here, which I'm going to call R perpendicular, because this is a right angle. And so that's the distance, that's the perpendicular distance from the line to the point, the P for the axle. R perpendicular by this triangle would be the hypotenuse length R times, let's see, that's the opposite. So sine of the angle theta RF. So I can think of the torque as R perpendicular times all of F. That is, if I associate the sine of the angle with the distance R, then this side of the triangle gives me R perpendicular, and it's as though all the force is applied at that point. I get exactly, it doesn't matter where along this line the force gets applied, I get the same torque. And a lot of times, that's the way to calculate to make your life easier. You can also extend and prefer this direction for the radial vector, and then choose only the component of the force that is perpendicular. And so in some problems, it might be more convenient to do that.